So good evening, everyone. Thank you, Abhishek, for that presentation. So now Frutura is part of Accenture, so technically whatever he presented is all about Accenture now. So having said that, while Derek and team is trying to solve the problem at a digital twin level, right, from a physical assets perspective, some of the problem statements what we face from our customers is, while this is happening, we understand what's happening, but from an enterprise perspective, how do I solve for this particular challenge? In the sense, because of some asset failure, there is a down in production. That production has gone down somewhere, but there is a demand coming up in my systems, basically integrating with your SAP ERP kind of systems, right? So how do I manage my operations in such a way that my production is maintained, my margins are maintained, and the carbon emission is controlled, is kept at an optimum level? So this is one of the use cases what we want to showcase today. So Pallavi from my team, she'll be demoing that particular use case. After that, if time permits, would also like to touch upon the carbon emission problem. So the problem statement here is, most of the times what we see is in retrospection, we'll come to know what is the emission which has happened from a scope 1, scope 2 perspective, right? But the challenge what our customer gave to us was, I want to know on a near real-time basis what is my carbon emission. And not only that, I want to know how that carbon emission can be brought down vis-a-vis my production and my economics. In the sense, if I want to bring down the carbon emission, can I just figure out a way to kind of reduce the production from certain wells or increase the production from certain wells where the carbon emission is not so high, right? So that how can I kind of manage that kind of arbitrage which is available to me, right? So that is one of the problem statements what we had. And in addition to that, we also have figured out how do we measure the methane emissions, because as we know, methane is more potent compared to carbon, right? And so how do we measure that? And for that, we have used some really cool technologies, I would say, satellite images, some real different types of sensors, which actually helps us to measure and monitor methane emissions and then take relevant actions from there. So with that, I'll hand it over to Pallavi to talk about the asset optimization from a asset perspective, and then how do we manage the enterprise level optimizations from there.
Thank you, Shri. Good evening, everyone. I am Pallavi. I'm part of Accenture India energy industry. So today, I'll keep this very short. So this is about how enterprise digital twin helps us to see the impact of availability and reliability of different equipments on the productivity and profitability, right? So far we have been seeing there could be issues with equipments, in terms of, integrity or availability. But how does it impact my overall operations? How about my profitability? So we have a solution called Enterprise Digital Twin. As you can see, there are fields, different fields, on top of which you have the OT systems. On top of the OT systems, there is a layer of digitization which we have created, which is the optimization twins, as we call. AODT stands for Asset Optimizer Digital Twin. And this is very specific to the type of asset, because the equipments, the process within each of those fields will be different, right? So for each of those kinds of assets, we have a separate Asset Optimizer Digital Twin. So what does this do? The Asset Optimizer Digital Twin, for example, it takes inputs from systems like Medium for reliability, even from Cerebra for reliability, LIMS for quality inspections, SCADA, PI tags, and tries to see what is the best possible way to operate so that my productivity and profitability is at the max, right? So along with the system information, the enterprise system information and the operations information, it also considers the market intelligence. So the production, as you know, the oil and gas prices are very volatile. It has to be, the production has to be in terms of what is the market demand. So with the information of the underlying capacities, the network, the availability, plus the market demand, how do I put together all of them so that I get the maximum profit, right? So it gives you a blueprint of operations for the next cycle of, next financial cycle. It gives you a blueprint of exactly how a maintenance department should work, how a carbon department should work, how a utilities department should work within your field, and post the corrections, delta correction and approval that is fed into your field changes, right? On top of it, of course, we may not be able to cover it today, but we also have an enterprise optimizer which dictates the capex, opex, and the production volumes in alignment with the organization goals into each of these twins. So now, without taking much time, let me go to a demo video, because we made a demo assuming that there could be network issues. So what I'm going to show you now is not necessarily at equipment level, but at a well level, right? So this particular diagram is giving you actually a blueprint of operations, as I said. What you see here is various scenarios. I can be checking how to run my operations, be it for maximum margin, maximum production, or even my carbon neutrality goals. For each of these goals, I'll be presented with how you have to run the operation with respect to your production, BOE production, or gas processing, or oil storage. And as the video unfolds, you will see that the entire operations of how much you have to produce and how you have to produce is all codified for you. So you just have to give this, the baseline one, to your operations team, and rest assured, with everything put in place, you will get the maximum outcome, as per the engine optimization engines. Now it also gives you financial details, and monthly, we have assumed a 3-month quarterly financial cycle, and it gives you a deep dive of all this. Not just this, now this engine also in the backend has different networks, capacities, what are different connections possible, what happens if my equipment fails, what happens if my pipeline is not available. So how do I reroute? And I can on demand run this model to get a new blueprint and the plan of operation. In the next, in couple of seconds, I think it will also show you how the network looks, right, for the different operations. I think I was just telling you that in the scenarios, you can choose any of the scenarios you want, and post that, you will also see that it gives you a network, right, based on the options you choose from in the scenarios tab for maximum margin. Not only tells you how you have to connect your different systems in terms of water. So we're actually talking of different departments here, right? Water department, carbon department, maintenance department, and all of them have single view of how to run it for a specific objective function, which could be your production, margin, carbon, or whatsoever, right? So of course, you can always double click into wells or equipment, and you can see for each well level, it will give you a financial parameter. It will give you a projection, and all of them are futuristic for the next 3 months. So this helps for a very agile decisions. We have many more of this AODTs. For example, LNG value chain optimization, which optimizes the LNG demand and supply, making sure your plant, your field, upstream field, plant, and your cargo are all optimized together. So this is the power of optimization. Of course, there's one more module on well, but I want to stop here and give an opportunity to my colleague also to cover the carbon part. Thank you so much for your attention.
Good evening, everyone. Due to the paucity of time, I'll just go through the video, and I'll just explain that how satellite imagery is being used to detect the methane emission. So we know, right, that currently in this century, emission problem is one of the biggest challenge we are facing as an industry, energy industry right now, and methane contributes to the majority part of it. And it's become a HSE challenge also to monitor your methane emission, fugitive emission coming from a field, from your wellheads, from your abandoned wells, from your long cross-country pipelines. So it's get difficult to monitor those emissions from one single equipment. Hence, the satellite infrared imagery helps you to cover your entire basin or reservoir in one go, and it quantify in terms of ppm that how much emission you're getting, and then our engine converts it into the flow rate to quantify that how much emission you're getting from each equipment. So here you can see on the screen that we have different maps, different wells on the screen, and if I click on any of the well, we'll be able to see how much emission we are getting from that particular well and how much production we are doing in that particular well. So the data coming from your OT systems, your IoT systems, and from your satellite imagery comes together to give you a bigger picture and quantify the emission with a certain certainty that, okay, we are getting emission on this particular equipment, and you can go ahead and create a work order, automatic work order scheduling, so that it gets treated then and there instead of doing it after probably a quarter or probably 6 months down the line, right? And then if you see, right, we can also getting the data from your ERP system, that what was the alerts raised in the history, what is the current methane emission we're getting, what is the flow rate, captured on which date, and then we can go ahead and see also that what type of work orders have been raised in a particular well. So we have a planned maintenance work order. We can also go ahead and see what are the venting work orders or the fugitive emission work order have been raised for that particular well. If not, then we can go ahead and create a work order, and which can be auto assigned to particular operations engineer to resolve that. Now this particular part even helps us to identify the fugitive leaks, and also to sort of understand that maybe there's an asset integrity problem. Maybe one of our colleagues in the morning were talking about that we are getting a lot of fugitive emission from our walls. So this helps you to sort of quantify on a bigger scale that from which particular equipment we might getting a emission, and you can go and resolve that. So, and we also have the system's also able to connect to the real-time system from your IoT devices, where you're able to see what is the temperature at the flare, what is the pressure of the flare tank we are having, and even if there is a challenge, you can go ahead and point out those challenges in real time and try to resolve those issues. It even helps you to, for example, you are having you're doing a regular flaring. Suppose you got a high wind and the pilot gas turned off. Then instead of not getting notified a certain time after, you get to notify then and there, and you raise a work order so that operation engine goes and resolve it quickly, and you sort of resolve your methane footprint or carbon footprint as a whole company perspective. So the systems even point out that what particular time frame the event is happening, and why it is happening, and the probable causes of that event, and you can go ahead and rectify those. So with that quick demo, I'll just pause. Maybe if you have any questions, we can discuss on that.